Okay. Hello, everybody. Today lecture is about image acquisition. In the previous few lectures, we have discussed different issues regarding image files and reading image files. When we talk about image acquisition here, we mean that there should be an instrument, a device, like a camera or a scanner, through which we acquire the images and convey them to the computer. This is very essential in computer vision because the computer needs at first to have the image, then process it. Anyhow, nowadays it is easy to acquire images and carry out processing and analysis online, and then after that, for different reasons, to save the image in a specific file. Or it may be required to acquire the image, save it in a specific file, and later on carry out processing and analysis offline. Devices required for image acquisition are the camera, the lens, lighting source, and triggering devices, and maybe other additional elements. In order to connect between the camera and the computer, we need a camera communication interface. This is called a bus. These buses may be categorized into two major categories. The first one is that the communication interface or bus is specific, standardized type integrated to the computer interface cards. It is called frame grabbers. The other option of communication interface buses is the common communication interfaces, such as USBs, Ethernet, Firewire. These are the most common, I think, three types. They are provided as standard configurations in most computers. And once we have decided to use either of them, we can consult the National Instrument website, ni.com camera, and select from there the appropriate camera for this interface. Concerning cameras also, they could be classified into two major groups: color cameras and monochrome camera. Before selecting the color camera, you should know why you do that and justify your selection. This is really because many times you can benefit from additional information provided by color images versus monochrome images. But the bad thing here is that the image, the colored image, needs large memory area in the computer comparable with grayscale images. It's about at least four times more space required. And more important also is afterwards, when you try to carry out processing and analysis, it is easier and simpler, less time consuming to deal with grayscale or binary images rather than with colored type images. So one should know what to do at the same beginning. And of course, anyone can consult with other people also to have a sound selection and decision. When working with acquisition, we face the concept of frame rate. Frame rate means the number of frames or the number of images we acquire per second. Most of the time, the most common is to acquire 30 frames per second. But of course, you can acquire with other rates upon request. Yes. Also, you can face the terminology trigger of signal or trigger signals. These signals which are required to synchronize the image acquisition with respect to external measurement devices, light applications, motion of a stage, or audio signals. So triggering devices are also necessary in similar applications. One issue which is also and always mentioned when talking about image acquisition, it is the resolution of the camera. We require the resolution to be very high, and really the decisive element here for resolution is the image sensors. The pixel size, pixel area must be as small as possible. The smallest possible size of the pixel defines the resolution of the image sensor. And of course, the more the number of pixels in the image, means that the image is more perfect and with high quality. Here, it is really useful to mention that zooming or the zoom length can be used also to increase the image resolution. Remember when we discussed some examples in the previous lectures, while importing or reading the images from files, there we also used the concept of X image sensitivity, X coordinate or X axis sensitivity, and the Y axis or the ordinate axis sensitivity. And we measured it for different applications. And here also we refer to the same topic. And I want to tell you that historically, the resolution of X and Y axis is adopted as 640 by 480 pixels. But of course, this is not a must. Also, you can select other dimensions in pixels depending on the situation and the volume of the image. Recommended, as you see here, 640 by 480 pixels. This is a standard also size, 752 by 582 pixels, 1024 by 1024, or 1280 by 960. Anyhow, you can refer to different websites or references to find a list of recommended sensitivities of images. Concerning the light source, really, it has a main purpose here, which is to differentiate the background from the object. It means that we need to make the contrast between the background and the image as high as possible. The light intensity difference between the background and the foreground must be as high as possible in order to figure out the features of the image and to extract information, safe information about the image. This is done by using lighting. Yes. So the imaged object should have enough light intensity difference with the background in order to distinguish it from image surroundings. Shortly speaking, to optimize the contrast in acquired images, proper lighting is essential prior to image acquisition. Really, the effect of lighting source and the quality of the sensor and the focusing techniques used with the camera and other elements which define the quality of the image is very, very important, because the best quality you get from the image, the easier it will be for you to process it in the future and to get information for the sake of analysis and measurements. If the image is noisy, so there is a problem and you need to begin a series of filtering and other different activities so that you make the image appropriate for using different algorithms in analysis or pattern matching or different activities. So at the same beginning, try to have always the optimum possible image so that to minimize the work and difficulties which you may face in the future. Okay, finishing with this short introduction, now I will introduce to you the MAX in LabVIEW. MAX is an application. It is a measurement and automation explorer application. It is supplied with LabVIEW directly. You do not need to download it or to purchase it separately. Also, I would like to say that MAX is very fruitful and useful instrument for the sake of configuration of different hardware equipment and software equipment which is installed or connected with the computer. The input-output devices, for example, the input-output analog and digital ports, all are could be configured by using MAX. Here in computer vision also, MAX with its software can acquire images and can be used to configure the imaging equipment or imaging system in general and test in a short time the imaging system directly. Yes, you can take one image or a series of images. It depends on the requirements. And by selecting the appropriate type, you can go further on your work. Okay, how it's there and how to work with it. I shall go with you now and show you how to find it. When you go to National Instruments, the installed LabVIEW, there is a very large folder for National Instruments. Here it is, National Instruments. If I open it, there is a large number of applications associated with it and tools. But here you find two specific applications, National Instrument Launcher and NI Max, National Instrument Max. This Max, when I click it here, opens. This is our application which I am talking about. When it opens, as you see here at the left, the root of the system And you see here the devices and interfaces. You expand it, and you see here that it shows that there is an integrated webcam called camera 0, cam 0. So to my computer, there is one camera integrated with the computer, and its number is 0. This is really the camera which is usually connected with the laptop. But you can connect with the computer also other cameras upon request. This Max will show you then, in addition to cam 0, the other cameras which are connected to the computer, such as camera number 1, number 2, and even it gives their models and serial numbers. Now, to work with this, you need only to click it, and now the page is opened here. As you see, you will have this page. This is the working area. Here, without writing any program, you can take one image only by pressing on the snap action button here, snap. Also, when required to have or to convey a series of images continuously during a specific time, you use the grab push button here. After snapping or grabbing, and you can save the images here using this button. Save the acquired image to the disk. You have to specify the location as usual where you want to save it. Here we have also a button titled histogram. Really, we have, as you will see in the future, we have two measuring tools which measure the quality and some statistical values of the image. One of them is the histogram, and the other one is the histograph. The histogram here is installed. And as you know, in literature, when we talk about histogram, we normally divide the area of interest, the range of values in any data set, we divide it to different classes. Normally, they should be about 10, but they could be increased to 16 values even, 16 classes. And within each class, you draw the frequency of repetition of each value. Here, the values which you are interested in is the intensity of light within the image. Okay, so if we want to work with it, I have to press the snap, and because the camera is installed and directly can see me, the first thing expected is to see my image. Let us do that. Here, as you see, this is the image appearing with the background. Of course, I can put any piece of equipment, and I can show you that also it will be shown. If I snap again, as you see, this battery, for example, is shown also for one time. This mode of acquisition is common in industry to have only one image at a time. But this is not really the most important here. I can press the grab here, and then I shall see now an image at every instant. You look at the image here. As I move, it moves instantly, and it can store all these movements, all these frames, depending on request. So this is a continuous mode of acquisition. The histogram here, if you want to see how it works, you just press this knob, and you will see, because the image is colored, you will see three colors, three different colors. And here is the x-axis where we see the different classes, the first class from 0 to 50 pixels, the other from 50 to 100, the other. So 1, 2, 3, 4, 5, 6. I told you it could be extended to 16 when necessary. And here at the height really are the pixels. Number of pixels per class within each class. So as you see here, Max is very useful to work for testing and for configuration, because it can give you some information about the images quickly and can show you that your, for example, your camera is working perfect or not, or as you want. So this is a briefing for you about the Max and how Max works. But of course, our work is not depending on Max only. We shall work with other more interesting tools and wizards used in LabVIEW. So I leave this page and we continue our talk here by saying that when we acquire images, we do not acquire images only, of course, by the Max. We mostly use NI iMac DX palette, where there is a number of functions which are involved with image acquisitions. How to see that? As I told you, if I open LabVIEW and I open the block diagram, so here the palette of iMac arises. This palette here, if I click it upwards to see, so we have here vision utilities. This is expandable. Image processing, also expandable. Machine vision, vision express VIs, and our interest palette, the palette of interest is NI iMac DX. When you expand it, it shows you that there is a lot of functions which are used for image acquiring. When we acquire images, we can do this by using the basic elementary functions which are existing here. This is called low-level programming. And also, we can use higher level tools within LabVIEW, such as the vision acquisition virtual instrument and such as the vision assistant. Where they are, we go up. Again, here we find Vision Express. Vision Express, generally, in LabVIEW, the word express refers to a high level, more complicated virtual instruments which are designed to help the engineers to carry out jobs quickly without using elementary functions. When I open it, we have two tools of this, two marvelous, powerful tools. One of them is the vision acquisition. This is for acquisition purposes. We will work with it today. And the other one is vision assistant. Vision assistant is dedicated for the purpose of analysis and processing and image or computer, let me say, imaging and working with the problems of image matching, color image matching, or particle image matching, and different advanced concepts in machine analysis or in machine vision or computer vision. Some people call it computer vision, some others call it machine vision. Anyhow, they are both interchangeable. Okay, so now we know in advance about what I am talking, that in addition to Max, we are going to work with other acquisition equipment. But let me tell you that the most interesting, which shows all the details in general, is to work with the low level. But if you are an engineer with a good background, so you may not need to work with element or primary low-level functions, or you can work directly with image, with vision assistant, or with vision acquisition. Okay, so now let us work with these functions. I first want to describe, to go with you somehow gradually, step by step, to complicate the examples which I am illustrating for you. So let us first begin with this simple program here, or VI, basic live image acquiring. Okay, let me open it for you. Now it is opened. This is the front panel, and this is the block diagram. The block diagram here, as you see, consists of different low-level functions which is used to acquire an image Upon desire, if we want, we can acquire one image. We can carry out the snap action, or we can carry out the grab action. So what is needed here? The first element here is the open camera VI. This is needed to communicate with the camera and to open it. This is a software package, a software program, which is used in order to open the camera. The palette, here it is. I will show you how. Here we go. We open the iMac DX. Here is the open iMac. You can read at the headings there. iMac DX Open Camera VI. I have written for you Open Camera VI. As you see, it is connected with the camera. The camera has a title, Cam 0. In LabVIEW, it is called the session, and this port here is the session input, session N. How it is created there? Very easy. I can take it away to show you how. Now we are in this situation. I just put the cursor on the port session N, right click it, and select create constant. I have this box now. Sorry. Yeah. This box now. I expand it a little bit and select here the type of camera which I want. Here I have only camera 0, so sorry. Camera 0 now is there. So camera 0 now is connected through the software with the open camera virtual instrument, and this function, as I show you, is considered one of the low-level elements. The second element here is the configuration element, which is used to configure the acquisition system. Here you can define, for example, the number of buffers required or frames in the buffer and so on. Suppose you are working or reading a block diagram and you do not know exactly what does it mean, this configure grab VI. Here it is written, and here it is also. Just right-click it and go to the help and press the help. You will get a specific page for the grab configuration of a grab VI. It gives you here some description about its function and what it do. And as you see here at the left side, we have the inputs to this VI, and from the right side, we have the outputs. At the inputs, you get the session N, and you have another input, number of buffers. You do not know what does it mean? Okay, number of buffers specifies the number of buffers the driver uses internally for continuous acquisition. So this is used internally by the computer, and you suggest the value you want, 5 or 10 or 15, makes no difference. This depends on the size of the image. At the output here, really, you get the same input. The session in and session out is the same, and it is used to connect all the elements of this system with the computer. So I know what is graph. This is the session out connected with the session in here. And the session out of this configuration of the graph is connected with the session in of the following element, which is grab function. And the last function here is the function which is used to close, here it is, which is used to close the camera. This oily or green light cluster carries out information necessary about errors, occurrence of errors. And if there is an error, you get a message here telling you the problem. Sometimes you may need to open this cluster. You need to use an unbundle function. Okay, you right click here, go to cluster class and variant, go to unbundle by name, unbundle, click it and put it here. Now, if you connect this cluster with it, you can see the internal data which is in the cluster. You have information about the status of the program. You have the number, the code number of the error, if there is an error existing, and the source of the error and why the error happened. This is called unbundle because all this information was bundled together and carried out through one bundle here. Now it is unbundled, opened, and because when it is opened, it gives you the name, so this is unbundled by name. Of course, you can unbundle without using names. This does not give you an idea about each of them and how it is. So you can go there at cluster and variant and unbundle. It will do the same, but it will give you the elements which are bundled within the cluster in organized in an order as they were written inside. As you see here, A, B, C shows you that this is a string, a name. This is integer 32, gives you a number. It seems to me that this is the number of the error code. And this is a true false, which gives you the state of the process. Is the state okay or false? If an error happens, this will be activated and can stop the program. Well, I'll show you that during discussing other examples. This element at the beginning, as you see, we know now this element. It is, as you see, dedicated to create. It is dedicated to create a memory or to allocate a memory area in order to put there the image which we will acquire by the camera. Here is the image. So the output of this function is connected with the grab. Here you can read image in. So this line of information is dedicated to put the image there in this memory, which is created using this function. It is given a name, live image. Why live? Because here we are not working with an image in a file. We will take the image directly. It is live. So to differentiate both from each other, it is called live image, for example, or we can write Ali image or Muhammad image or whatever it is. And here you also, we decide what is the type of the image used. It is red, green, blue. So it is a color image. Uses unsigned integers, and the depth of the word of each color is 32 bits. You know that. I have explained this before. Okay, so what we expect then, that at the output of this IMAC grab, the grabbing function will give you the image outside, and this image will be here. So we have got the image, and after having the image, this function closes the program. So when I run, of course, when I run now, I will get another image. This is before done. Now I am against the camera. So when I run here, I will get another image. This is my image now. And to remind you, as you see here, it has the size of 640 by 480, as I told you in this lecture at the beginning. As you see, this is 32 bits per plane, per color, which is red and green and blue colors. And here is the values of the red and green and blue light intensities at different pixels. When I put the cursor here, there is a value, and I put a pixel here, they are different depending on each, on the position of each pixel. And the position of each pixel is shown here, as you see. So I am not going to repeat myself that much, but just reminding you about it. So again, if I take another image, you will see, of course, it depends. Let me put something to show you. For example, this mouse with me here, and when I run it with the mouse in my hand, maybe it will show you. Here it is black, not shown very good. Here it is the mouse shown, but let me show you the white side of it to be clear. Here it is. Now the mouse is seen clearly. So you can use this program to take image of anything, and you can save it in a file as you want, and you can, of course, print it and make use of it. It now works as a scanner. It is working as a scanner upon request. Okay, now we have discussed with you the acquisition by using Max, and I have also shown you an example by using elementary functions of IMAC DX. Well, it seems to me that I have time a little bit. Let me try to give you an idea about another program. Maybe it will take 10 minutes more. Let us say that we want to take 5 images. This is, no, let me say more, acquire image using camo, and vision assistant. Okay, let us work with it in order. This is number 2 program. This is the front panel, as you see, and here is our program. This program uses both the vision assistant and elementary elements, functions used in iMac DX. What is new here? See, the iMac DX grab, which is the function which takes continuously a number of images, is put in a while loop. This is specially specially required for implementing the code which is inside this loop continuously until you press a stop. Where is the stop function here? The stop function is here, here it is. But the stop function is connected with the terminal of the loop, which terminates the loop through an OR function. This is an OR function. So at first, this loop will be disabled if this is active high, when this is true. But the loop will stop and the system will stop not only by pressing this switch here, but it also can be stopped by using the information which comes through, as I told you, the error cluster. How it comes, as I told you, you can directly connect it as seen here, or really you can, okay, disconnect it here. Now you put unbundle by name and connect the cluster with it. And now the status here, if it is high or low, switches the system or doesn't switch the system. You can put it in this way, or if you connect it as it was before, it gives the same effect. But this is maybe clearer and shows to you what happens inside the cluster. Anyhow, it makes no, let it keep it as it is, no problem. Okay, so as discussed before, this is the iMac DX open, and it is connected with the session N. Here, session N is not shown as a constant, it is shown as a control. So if you press it and go to the front panel, you will find it is the same. Camera number 0 is here, nothing more. If you open it, you will have nothing except it. So just instead of creating a constant and to see directly what there is, I have preferred to put the number and name of the camera at the front panel. So the same thing here. This is the session in. And the session in and session out are the same until you go here, until you go to the border of the while loop, and to the input here is also session in, to the input of the closing or iMac close camera virtual instrument. As you notice here, I have put the configuration function and the opening function outside the loop. But the grapping function is put inside the loop with the vision assistant. Here it is important for you because this function only works one time. Just you input the session number and name, and you supply the memory area to this function. This function will repeat continuously depending on the state of the switch here or the state of the system if any error happens. So because this is repeatable, it should be done, put inside a loop to be repeated the required number of times. What is the need of the vision assistant? Practically, I can do without it. It is just shown for you to tell you that vision assistant can give an output. The output of this is here, as you see, go image output. The image output of the grab function is input to the vision assistant. And now it is the image output. So practically the image here will be the same image as here. There will be no change because I did not manipulate or change anything inside the vision assistant. The image here is given a name. This is, as you see here, a string. Inside it a number, which means image number 1. And it is given here a grayscale. It is not a grayscale, really. It is more, to be more specific, it is RGB image. And now when I run the program here also, we will get this image. Now, of course, the image has changed because that image was taken before. Now the image is taken as I am doing, and you see it is also continuous. As I move my hand or I move my head, every moment of time, there is a change. So we are continuously acquiring the images. We do not acquire only one shot. No, it is a continuous grabbing. And the image which is here really, which we see. Of course, we can see it from here. Let us try, for example, okay, let me stop the program and connect here another indicator. So what should I go? I should go here and create a display. I have to enlarge it to be seen so that there will be space for it. I have to shorten it a little bit. It is too much big, not necessary for us. And now when I try to, okay, I have to connect it with the here. So where it is here. I want to make it smaller as an icon, and I connect it here with the output. I assume that we shall have the same image. The same. No difference at all. So the vision assistant here is shown to you just to make it easy, to make it for you to understand that this could be done and you can work with it because you can, we shall see in the coming lecture that we can do some things inside the vision assistant and by using also the vision wizard. Well, I think today is sufficient for you. Tomorrow I shall continue discussing with you other different programs with different, of course, content and different flavor. Okay, see you in the next lecture and goodbye.